Hi everyone. In this video, I'm going to try to explain what do radicals actually mean. So what does a radical number mean? How do we solve this? To solve this using a calculator, please watch the other video. This one is just an explanation of what radicals mean and how do we do it algebraically. So first of all, when you see something like this, square root of 16, what does that mean? So in English, it's asking you what number multiplied by itself twice, 2 times, is 16. Where did I get that 2 from? When the index is 2 invisible. Again, this is explained in the previous video about when we're using a calculator. So when you see a square root, you don't see the 2, it's invisible, but that's what it's assumed it's there. So this question is saying what number multiplied by itself 2 times will give you 16. So think about what same number that you can multiply it by itself twice to give you 16. And that could be a 4. 4 times 4 is 16. So the answer is the number that you multiplied by itself was 4. So the answer to this question, square root of 16, is 4. But there's also another number. You could also multiply -4 with -4, and that will also give you 16. So another answer for the square root of 16 can also be -4. If you see the index to be 3, then that question is asking, so this is now a cube root of 27. This question is now asking you what number multiplied by itself 3 times is 27. And you would give that answer to be 3, because you know that 3 times 3 times 3, a number multiplied itself 3 times, is 27. Now you can see that the index is 5. So this one is asking what number multiplied by itself 5 times is 32. And the answer to this is 2. Because 2 times 2 times 2, and if I do this 5 times, it will give me 32. So this is another way of asking us what the square roots are. Squares, cubes, fifth, fourth, any of those, what do they mean? Okay. In this course, so this is a page from your book, this one is asking us complete the following statements, and we just talked about what a square root of 49 would be. So written in a radical form, this question would look like this. What is the square root of 49? And you would answer that to be a 7. And like I said, negative numbers also multiply to become a positive one. So the answer to this could also be -7. So what is the difference and when do we use which one? So for this unit, we will be using the positive answer when we take a square root of a number. Even though there are 2 possible answers to it, we will always be just using the positive number. The positive square root is called the principal square root, and the negative one is called a secondary one. And for this unit, because we will learn to do a few things with these radicals, to keep it simple and not to make it confusing, we will always be using the positive answers for a square root. Again, I'm going to repeat, only for a square root. Okay, so this is the only time where you can have 2 possible answers is in a square root. So if you see the 2 answers, so if you see what is the square root of 64, you will simply say 8, even though -8 is a mathematical correct answer. Okay. Another thing that we will also talk about is that sometimes you will get these nice numbers, like the square root of 36 is 6. But other times, some numbers don't give us a nice answer, like the square root of 35. So if you can't get a nice answer, an exact number, you can either have a decimal number, but this one is not exact because we have to round it. This answer actually has quite a few long number of decimals. So this is not an exact answer. This is a number with whole bunch of decimals, but you could round it to a point. Or if you want to leave it as exact, you would leave it as just square root of 35. And we would do it in the simplest form, which you will learn later. Okay, so what did this slide just ask us to do? It says if you're taking a square root, even though there are two answers to it, a negative and a positive, we will only use the primary principal square root, which is the positive one, okay, in a square root. Now, a few other things to kind of talk about. Can you find a square root when our radicand is negative? So this is different from us finding the square root of 16 is negative 4 and positive 4. In this case, the radicand itself is negative. So again, the question is what two numbers that you can multiply, which are the same numbers, that can give you negative 16. So sometimes students will answer me and say, well, 4 and negative 4. Well, those are not to the same exact numbers. They're different numbers. And in radical sign, it has to be the number multiplied by itself, exact same number. So it can't be one to be positive, one to be negative. They both have to be either positive. So if they're both positive, that would just equal to 16, not negative 16. And if they're both negative, and it still ends up being a positive 16, not negative 16. So there is no number out there that can multiply to itself and give you a negative 16 answer. So this is not possible. So if you see any time the index is an even number, you cannot find that. You cannot find a number multiplied itself even times to give you a negative number. So anytime you can do a mental check. If there's a radicand which is negative and your index is an even index, you cannot do it. Even if you try to do this in the calculator, it will give you an error there. So that's a check for you. However, if you try to find a number that can multiply itself 3 times, because the index is odd here, and it will give you negative 27, yes, negative 3, negative 3, and negative 3. This is the only possible combination, okay? Because negative times negative will give you positive, and then positive times a negative will give you back negative. So the cube root of negative 27 is negative 3. The cube root of positive 27 is just a simple positive 3. Okay, so this doesn't have those two possible answers. It's only one answer. So the main idea here we're trying to find out is that if the index is even, your radicand cannot be negative. And if your index is odd, then your radicand can be a negative or positive number. It doesn't matter. So here's some examples that we can take a look at in your book. This is on page 272. So this is saying without using a calculator, find out if it's possible to do this. So first I see my radicand is a positive number and my index is even, that invisible 2. So what number multiplied by itself twice will give me 64? Well, it's 8, because 8 times 8 is 64, twice. And now in this case, what number multiplied by itself will give me negative 64? Well, it's not possible. Again, my index is even. I cannot have a negative number here, because negative 8 times negative 8 still will give me a positive 64. Part C, the negative is outside the radicand, so it really doesn't have anything to do with this negative 64. It's almost like having a negative 1 in front. So that's a different, separate. So it's almost like seeing a negative 1 times the square root of 64. It has nothing to do with this one. So you can answer this part. The square root of 64 is 8. And when that it's multiplied by that negative in front, the answer this will just become negative. So that negative was outside. So that's why it didn't have anything to do with my 64. This one here is asking me to find cube root of 64. So that is a number multiplied itself 3 times to give me 64. And the answer to that is 4. 4 times 4 times 4 is 64. So that is 4. Now again, here the negative's inside, but I'm okay because this is an odd index, and negative 4 multiplied 4 times will give me negative 64. So that is the answer. The last one will give you the same answers, but they represent a different thing. Here the negative is outside, so it's almost like again having outside, and I'm going to figure out what the answer to this is first. So that one I know is 4, but there's a negative outside, so the final answer becomes negative 4. Same thing what it did in part C. So whether the negative's inside or outside, it ends up giving us the same answer, and that happens in math sometimes. So that's an explanation of what radicals are, and I will do some more examples in the next video.